So we have been seeing. Yes, maintenance levels. Recording Santosh? Yeah. Hello, last one. Maintenance levels. See here. Yesterday we have seen two IoT enabling technologies. That's all right. Yes, sir. So this is class again. IoT enabling technologies. Yesterday we have seen embedded system and wireless sensor networks. So other three IoT enabling technologies are, tell me.
Big data,
Big data analytics,
cloud
computing, communication protocols. This we have seen in the physical design. This we have seen in the physical design. Yes or no? Right. So yesterday we have seen this and this. Today let us see these two enabling technologies. Clear? Okay. Let us see. Now let us take real life examples. Your mobile is an IoT device.
Yes.
What kind of data it is generating? Tell me. Suppose your mobile. What kind of data it is generating?
Text, image, voice data.
Yes.
Images,
Images,
voice,
your selfies. Right. So you are generating images and uploading to Instagram. Yes or no?
Yes.
You are everywhere on the road, right? You will be taking selfies, right? Something new you have seen, right? Some new creature has arrived, some new dog has came with that dog also take selfie. Really, some puppy came with that. So you are generating images on social sites. Your geolocation. Yes or no? Your geolocation is all in your mobile phone. You can check it out.
Yes.
Almost all the applications require that permission. They will ask your geolocation. Yes or no?
Yes.
So it is continuously your geolocation is monitored. Yes or no?
Yes.
Continuously it is monitored. See how much data it is generating. You are allowed cell phone. Here we have hundreds of students. Right? Imagine how much data it is generating. We have CCTV cameras. We have CCTV cameras. How much data they are generating? Every day you are doing UPI transactions. UPI transactions. How much data it is generating? You go to the shop here locally, you purchase chips packet, you purchase smoke bottle, you do UPI payment. Right, then you go on the road, you drink it and you throw there and you go. Right. So why can't you design application? Already cameras are available. We can monitor. Right, which student is littering the campus. We can identify that person. Right, use computer vision, do a project. Have a database of the student, photo, image, the person who is doing such thing, scan, match, and send file to him. Whenever he opens his records in RGKT hub, there is a file. At this time, at this date, this time, you have done this activity. File. Why can't we do that project? Not only for our campus. It's a good project, right? So, we are generating huge house data. We are generating very huge data. Right. Approximately by 2025, 2025, I think we have 20 million gigabytes of data worldwide. Approximately, from some source I got it. Right. So this huge data generated, the IoT devices which are generating this huge data, when we are going to call it as a big data, when we are going to call it as a big data. Anybody? As a computer science branch students, right? You have some idea what is big data? When we are going to call this huge data as a big data. Right, any answers from girls side? Right, so this data is big data, right? When we call this big data, it is so, right, large in volume, velocity and variety. Which is right. Now, what we say data. Basically, what we do with data? We store data. We organize the data, or I can say manage the data, process the data, analyze the data. That's all. Generally, these operations we do with our data. That's all wrong. So to do these two, we need database. To do these two, we need to this is database. Here we need to do data process. Now your data is so large, is large in volume, right? High velocity, variety, right? So it is difficult to handle. It is difficult to handle with traditional database and data processing tools. Clear? When we are going to say data as a big data, then right, whose velocity, volume, velocity and variety is so high, so that it is difficult to handle with. Okay, so I write here difficult. It is difficult to handle with traditional database and data processing tools. Basically, it is a relative term. It is a relative term. Right. So in 2020, suppose imagine we have called in 2020 it as a big data. Right. Now this data we have developed to handle this data. We have developed the tools. Now in 2025, again we have a data, but these tools are not useful now. These tools are not useful now. Again we have to develop the new tools to handle the data which is in 2025. Now in 2025 we have developed the tools, technologies to handle the data. Today's big data. In 2025 these tools won't work. Again we have to develop, we have to design and develop the new tools to handle that data. Is this idea clear? So how to define if somebody has big data? So big data whose volume, velocity and variety is so high, whose volume, velocity and variety is so high that it is difficult to handle with traditional database and data processing tools. Right, traditional database and data processing tools. Right, it is difficult to store the data, manage the data, process the data, analyze the data. Is this idea clear? Is this idea clear? Yes. Now, what are the different characteristics of this big data? So here itself, Right. What are the three important characteristics of big data? Three characteristics of big data. Right. Sometimes four, sometimes three in different textbooks, depending upon the context. Right. So three or four. Let us see which one is now. Volume. So high volume, large scale. Right. Large amount of data. Reason. High resolution photos, high resolution images. That's it. Is this idea clear? Everybody wants to put their high resolution photos. Everybody generates their videos, images. Everybody generates their memes, shorts, reels. Right? Everybody uploading it to the Instagram, uploading it to the YouTube groups. It's generating huge data. Right? Next characteristics is velocity. Velocity. What is this velocity? The rate at which the data is generating. The rate at which data is generating. Yes, sir. Again, I am generating the data here. Your CCTV camera generates the data. Your geolocation. It is the rate at which the data is generated. Is this idea clear? The another characteristic is variety. Variety is the diversity of data. Diverse data. Diverse data. Right. It could be your structured data, unstructured data. Right. For example, it could be your text, image file, image data, audio data, video data. Right. Your social media data. So this is a variety of data. The another characteristic that the fourth sometimes some books discuss, some books won't discuss is veracity. Actually, when it comes to the analytics, this is the veracity. Veracity is integrity of data. Integrity of data. Integrity means the data should be accurate data, right? Error-free data. Error-free. These are the four characteristics of a big data. Clear? Volume, velocity, variety, velocity. And what is this big data analytics? Big data analytics or analysis, whatever you prefer, no problem. This big data gathering the big data, collect, you can also connect as a collect. After collecting, clean the data. Right, cleaning. Then you can say mining to extract the information out of it. You do these operations, right? Then visualization. This we call it as a big data analytics. Now your geolocation data is gathering. Continuously going to the Google Cloud. Yes or no? Right. Now once in a month, once in a 50 days you observe your movements. How it is presented in virtual format. Right. What is the technology that it is using? What we call it as virtual reality or augmented reality. Google, the map that you are moving is augmented reality, right? Yes or no? It is augmented reality. Clear? So, what is big data analytics? All those big data that is generated, right? Gather that data, clean that data, mine that data, right? Visualize that data. This is the big data analytics. Now we have big data. Okay. But in IoT, what we say generally? Constrained environment. Constrained environment. I said in previous classes, constrained environment. What do you mean by constrained environment? Limited processing power.
Limited power supply.
Limited processing power. Limited storage capacity. Limited storage capacity. Limited power supply. Power supply or backup. Limited bandwidth. Is this true? For example, take yesterday we have discussed about forest fire detection system. Right? We have discussed about end nodes in wireless sensor networks. How small, how small are they? They are minute, right? So in such scenarios, I will be having all these limitations, right? Limiters. Now, but I am saying that IoT is generating big data, huge data. Here I have everything limited, but my devices are generating huge data, continuous data, monitoring data, control data. Then what is the solution? What shall we do? Yes, from girl side? Madam, suggest me a solution what to do. My IoT devices are generating huge data, but at the same time, these are limitations. Constrained environment.
Cloud.
Very good. Right? Cloud. So, we go for, what is the solution? We go for, solution is R2. Solution is cloud computing. Solution is cloud computing. Is this idea clear? What is your name?
Sai
Shiva. Very good, Sai Shiva. So the solution is cloud computing. What is this cloud computing? It is delivery of
virtual
network
storage
resources. network resources. The question arises, what are these network resources? See, delivery means don't imagine everyday Flipkart, Amazon person will come, they deliver, right? Don't assume, imagine that delivery. It is different delivery. Right, your delivery has arrived. Every time you see it, you open the Amazon, right? It has reached from, right, to Hyderabad, Kamareddy, Nizamabad, out for delivery, right? It is not that delivery, you will understand, right? So, delivery of network resources. What do you mean with network resources? What are those network resources? These network resources are, it could be server, it is your server, storage, it could be your data center, network, your applications, services. These are your network resources. Right. So how delivery of network resources on demand. On demand. It is important. On demand. If you need it, they will provide you. Unnecessarily they won't provide you, like YouTube advertisements. Right. When you need it, when you want it, then you can take it. Now we are Indian people. Right. If something is available, we will take it. Why we will do it? Right. So, then what is the solution? It is a paid service. It is a paid service. You have to pay for it.
Pay as you.
Right. What is that, Dolendra?
Pay as you.
Pay as we use. You will see different characteristics of cloud computing. Is this idea clear? For delivery of network resources on demand, paid service. Pay as we use. Pay as we use. Is it clear? Right. Let us discuss the 5 characteristics of cloud computing. 5 also, let us discuss one by one. Right. Suppose, now let us take an example. A farm. Not farm, farmland. A farmer. The farm is using IoT system. What it is using? It is using an IoT system. To which we have moisture sensor, humidity sensor, then we have temperature sensor connected to it. Right. Basically, in a farm, the agriculture activity is going on. Agriculture, floriculture, whatever it is. So, 3 important parameters which are measuring is moisture, humidity, and temperature sensor. Now, suddenly what happens? It rains. Suddenly it rains. The moisture sensor, right, get activates, right. So, many moisture sensors get activated and send frequent data. Send frequent data. Suddenly it rains, many moisture sensors got activated and they are sending the data frequently. They are sending the data frequently. Now what happens? The cloud provides Right. Increase storage. Increase processing power. Increase processing power. Without the notice of farmer. Without the notice of farmer. So this is the first characteristic of. This is the first characteristic of. What is this? On-demand self-service. It is self-service. The farmer has not asked him manually. The last point, hello, section. See here, that's not common plus we should not take. Right. So demand was increased. Frequent sensor data. I need storage. Right. So in the cloud, a virtual machine is created. A virtual machine is created which provided storage as well as the increased processing power. Without the farmer specially requesting for it. He subscribed for it, so self-service. On-demand self-service. This is clear. So this command, this part is on-demand. Right. So this part is self-service. Is this clear? Clear? Santosh, going on fine?
Yes, thank you.
What is the first characteristic of cloud computing? On-demand self-service. That I have explained in IoT context. Clear? Remember, we should be capable of using them on daily basis. You should be able to implement a project. So application oriented I am explaining so that it is easy to remember also. See, I have explained, I have demonstrated, I have illustrated, so it is easy to remember. You should not forget it. On-demand self-service. In this example, right, rain came, sensors activated, right, all these things. By application oriented, if it is in your mind, you won't forget it. One thing, you won't forget it. What is the second good thing? Is that you will apply. Whenever, right, that situation comes, you will apply. Right. Now, this same farmer monitor the mobile, monitor the sensor data of the mobile. He monitors the sensor data of the mobile. In a farm, there will be 2-3 workers. There will be 2-3 workers. They will be monitoring some workers. They will be monitoring on the smartwatch. All those sensor readings. Right. They will be monitoring on a watch. The same data collected will be, right, a scientist, an agri-scientist. An agri-scientist will also be monitoring the same data on his personal computer or workstation for research purpose. Right. So what is this characteristic called when people are watching it?
Multi-device support.
Right. So this is called as, this is the second characteristic. This is called as
Multi-device support.
bandwidth. Sorry? Sometimes even
did you read?
Yeah. Broad network access. Broad network access. Right. Broad network. This is the second characteristic. Right. Now, let us look at the third characteristic. Right. Now consider another scenario, another example. Smart city. Smart city. In smart city, what you have to do? You have to monitor traffic. Monitor traffic. Yes or no? Traffic monitoring in Hyderabad, in Secunderabad, you might have observed. Traffic monitoring. The policemen will be there. Some they use drones. Nowadays they are using cameras. Right. With intelligent features, if the traffic is more, right, there the time the runtime time increases. Right. For example, we have like this, 4 lanes like this. Right. So here more number of people are there. More traffic is there in this route. The green timer usage increases. Right, suppose here there is a less traffic, here there is a less traffic, so for these people there will be traffic light, so red light time increases. Right, so we in a smart city for monitoring the traffic, we have application for monitoring the traffic, smart light, smart street lights, they switch on automatically once it is dark. They switch off in the morning. Here also we have street lights. You can develop an application. Right. Every time what happens in a unit, the person has to roam around. Right. There is a special person. Right. To switch it on and switch off in the morning. Why can't be automatic? Suddenly when it is dark, it is in the unit, the light should start on their own. Right. So this is smart city. Then what else we have? We have air quality monitoring. Air quality monitoring. Pollution is also a big problem nowadays in the cities. Hyderabad, New Delhi. Right. So then we have smart parking. Enter a busy area, enter the bus stand, enter a railway station. Suddenly once you enter inside, you have realized that there is no parking slot inside the railway station. There is no parking slot. Now you enter the road on the railway station, you have checked, there is no parking slot. Now you want to put reverse, you have to go back. You see behind another 5 people have already come. This is the scenario in India. Yes or no? Right. So before entering the railway station, I should have an information in my mobile app that there is a parking slot available or not. Inside I enter a mall. Before I enter a mall, I should have information in my mobile that the parking slots are available in that mall or not. Is this idea clear? So all these are sharing, right? They are sending data to same cloud platform. Right. They have common pool of server, storage, and network. So this brings to our third characteristics. What is the third characteristic? Okay. So third characteristic is resource pooling. Resource pool. Right. This is resource pooling. Right. So now let us move to the next characteristic. Right. Consider the scenario. Smart energy meter. Smart energy meter. Smart energy meter. Right. Nowadays in Hyderabad, I think you also observe right? Prepaid electricity bills, prepaid electricity cards. You have to prepare for electricity. Like that you pay for your mobile set, prepaid. Like that you have to pay for electricity. We have smart meters there. Right. Once the currency overs, then the electricity cut automatically. Right. That facility is available. So smart energy meter. Normal operation. Scenario there is a normal operation. Right. Sending data every 30 minutes. And calculation 30 minutes. Normal operation, no problem. Traffic handling clearly, no problem. There is no network traffic. Now what happens? At 12 o'clock. At 12 o'clock, afternoon. Temperature raised to 41 degrees Celsius. Right. Temperature raised to 41 degrees Celsius. AC on. Power consumption is increasing. AC on means power consumption increases. Now these smart meters, now they have to send the data frequently. Right, so avoid the traffic at once. Right. Now again in the evening. Right. So what happened here? The peak hours, extra resources. Right. Extra resources like what? Processing power, storage. Again, at 8 o'clock in the evening, right, temperature becomes 25 degrees Celsius. There is no frequent sending of data. So what happens here? This because we are going to call it as a rapid. This characteristics we are going to call it as a rapid elasticity. Fourth one, rapid elasticity. When we need the resources, quickly we will, the resources are available. When we don't need it, the resources will go back. See, even if I reserve the resource also, right, I have to pay. It is not a good idea. Even if I reserve the resources also, I have to pay. It is not a good idea. So I have to leave the resources so that there is no charge for it. Is this clear? Right. Now finally, the last scenario is measured service. Last one is measured service. First one is on-demand self-service. Let us revise on-demand self-service. Second one is broad network access. Everybody? Broad network access. Third one is resource pooling. Resource pooling. Resource pooling. Fourth one is rapid elasticity. Last one is measured is done
Based on
for the amount of data stored, computing power used, or right, or network system that is what it is, pay for what you pay for what you use. These are the 5 characteristics of the cloud computing. Clear? Sure, sir. Start reading your attendance. What's the time, Vikram? 10:40. 10:40. Right. Then we have 3 important services. Cloud services. 3 important types of cloud services. You know, infrastructure as a service, platform as a service,
software.
software as a service. You can remember like this, IPS. Right. Now, perform infrastructure as a service, platform as a service, software as a service. In platform, in infrastructure as a service, you just have the hardware. That is storage,
Processing.
network. Storage, network, processing. Just the hardware part you get. So here, in second one, in platform as a service, what you get?
Development and
Infrastructure as a service plus developmental tools. Developmental tools. You have to design your own applications. You have to design your own applications. Developmental software tools. You have to develop your own applications. Whereas in case of software as a service, as plus
third party.
pass plus all those applications. Right, what? Just connect and go. Just connect and go. That's it. Just connect and go. Nothing you require. Just internet connection is required. One more important thing, right? What I said, right? Delivery. What is delivery? At door? Ting ting. No, it is over the internet. Over the. You should remember. I forgot at the time to tell you. Internet connection is required. Is this clear? Right. So by this we have completed this IoT and everything.